Hi, everyone. Let's go ahead and get started. I want to thank everyone for joining today. My name is Arun Sundaram. I'm a product manager with AWS Storage Services. And I'm excited today to talk about a service we launched back in January of this year called the AWS Storage Gateway. So I'll start today a little bit high level. I'll talk through some of the key use cases for the gateway. And then I'll jump into a little bit of the architecture and some tips on configuration. So where I'd like to start is this chart from IDC that gives you a sense of storage growth since 2006. Now the chart shows the data in exabytes, which probably isn't too applicable to folks in this room, but I think what is applicable is the shape of that graph, right? Where a lot of you probably were used to dealing with gigabytes of data, and you're probably now dealing with terabytes, or you were dealing with terabytes of data, and you're now having to deal with petabytes of data. And in talking to customers, what we found is, in spite of this data growth that you're seeing in your organization, you're being forced to do more with a limited set of resources. And we're also hearing that the traditional technologies and processes that you have in place on-premise just aren't scaling to meet the demands of your organization. So whether this is unstructured file storage like departmental file shares, home directories, or backup infrastructure for disaster recovery, or archival, what you're having to do is place bets on the amount of storage that you need to procure. And if you procure too much storage, you're left with underutilized capacity, idle storage, high capital costs. And if you purchase too little, well, then you're faced with having to do frequent hardware refreshes, which can be time-consuming, expensive, and potentially risky. So then what happens is, usually the backlash is, restrictive user quotas. To say, hey, I know you're looking for 10 terabytes of storage, but right now we can give you 5 terabytes. And so what we're hearing from customers, both small businesses and large multinational enterprises, is not only is this data growth a cost issue, but it's also impacting agility. Right? It's impacting your ability to move forward quickly as a business. And this is where the Amazon Simple Storage Service can help. Right? And I know we're going to be talking more about Amazon S3 tomorrow in detail, but I'll cover it quickly at a high level. So Amazon Simple Storage Service, it's storage for the internet, provides a bucket where you can put objects into that bucket. There's no limit to the number of objects you can put. You can scale up and down on demand, and you only pay for the storage that you use. So the key benefit there is that capacity problem is removed, right? Because you no longer have to deal with underutilized capacity. With S3, you're able to scale. You only pay, again, for what you use. You don't have to worry about dealing with provisioning storage for your users. You also no longer have to deal with the maintenance of that storage, whether it's backup storage, whether it's primary storage, reliability, power, cooling of that storage. S3 handles all of that for you transparently. You also don't have to deal with the hardware refresh cycle that I talked about, right? Every 3 or so years, when your support contract ends or your hardware reaches end of life and you need to move that to new hardware, S3 handles all of that transparently for you while providing a highly secure solution that's comparable to what enterprises are running in their own data centers. I'll drill into a couple of these aspects in a little more detail. So the first is, I talked about how S3 provides a high level of reliability. So we look at that in 2 ways. The first is around availability. So S3 is designed for 4 nines of availability. And when we think about availability, we really mean uptime of the service. So if you're doing a put of an object into S3 or a get, or you're listing the objects in S3, the ability to ensure that when you perform those request calls, that the service will respond. The other way we look at reliability is from a durability perspective. And when I say durability, I mean ensuring that your data is protected from loss, right? So that when you need to access your data, it's recoverable. And with that, S3 is designed for 11 nines of durability. And so how does S3 achieve this high level of durability? When you store data with S3, the service redundantly stores your objects across multiple devices, across multiple facilities within an AWS region. So when you actually put an object into S3, S3 redundantly stores that data across multiple facilities before returning success. So you know that when you receive a success on your put request, you know that your data has been redundantly stored across multiple multiple facilities. S3 is also designed to deliver a high level of security. And we look at security from a networking perspective, from a software perspective, and from an infrastructure perspective. So we have a number of certifications in place, like SOC 1 Type 2, ISO 27001. We have strict procedures in place to control who has access to the infrastructure in our data center. S3 also has features around encryption, enabling you to store your data in S3 with AES 256 encryption using what we call the server-side encryption capability. And when you use SSE, server-side encryption, S3 encrypts your data with an encryption key, and then encrypts that encryption key with a separate key. And those keys are stored in separate locations. But S3 is designed for storage for the internet, right? It's designed for access over HTTP, and it's designed for, it provides a REST interface. And what we've heard from customers is that for new workloads, for new applications, S3 makes total sense. It's a no-brainer, right? You just write your application to work with S3's REST interface. But what we've also heard is, when it comes to that data growth I was talking about, backup storage, file share storage, a lot of the storage comes from existing legacy workloads, legacy applications that customers are running on-premise. And for those applications, the value of S3 is still there, right? You still want to be able to store your data in S3. But we've heard requests for the ability to use those existing applications to store data in S3. And so that brings me to the AWS Storage Gateway. So the AWS Storage Gateway service, its primary motivation is to enable you to bridge your existing on-premise applications with AWS cloud storage. And we do this by providing a virtual appliance that you download from our website, and you then install on a host running in your data center. Now, when we initially launched the service back in January, there was a number of customers that thought that when we said virtual appliance, that they might actually be getting a box from Amazon.com in the mail, right, with an actual physical appliance in it. And I want to highlight that that is not the case, right? So it's a virtual appliance. So it's software that you would download from our management console. So when we think about the Storage Gateway service, one of the key tenets that we had was to ensure compatibility, right? Because we're talking about existing applications working with Amazon S3. And so we think about compatibility from three perspectives. So the first is around the deployment of the gateway itself. And so we've made the Storage Gateway deployable as a standard VMware image. Again, you can download from our website, and you can deploy it on a host in your data center running VMware Hypervisor. And you can use a paid version or the free version of VMware's Hypervisor. The second way we looked at compatibility was from the protocol itself. And so with the storage gateway, you can create iSCSI storage volumes that are backed by Amazon S3 that you can then mount to your on-premise application servers. So for example, if you're running a Windows application server, you can mount an iSCSI storage gateway volume, and it'll show up as, for example, a D drive, which essentially allows you to mount Amazon S3 as a D drive to your on-premise application server. And the third thing we looked at was performance, right? Because when we're dealing with this data growth, your end user shouldn't have to worry about whether the data is being stored locally or in S3, right? All they care about is that the data is being stored durably, it's being stored securely, and that they're continuing to have the same experience in accessing that storage. So to provide that seamless, compatible experience, part of it is the protocol, iSCSI, but then part of it is performance. And so the way we've achieved that is by storing the data up in S3, but keeping recently accessed, frequently accessed, really your active data set locally as well for low latency access. We've also designed the storage gateway to be flexible. So we had a number of customers that came to us and said, we want to be able to continue to store our primary data locally, all of our primary data locally for low latency access. But then we'd like to be able to take point-in-time snapshots of that data and store those as backups in Amazon S3 for offsite durable backups. And so for that request, we delivered gateway stored volumes. And so gateway stored volumes are iSCSI storage volumes that are stored locally on hardware in your data center. And what the storage gateway then does is it takes that data and uploads it transparently in the background to Amazon S3 for backups. But we also had a number of customers that said, look, we want even more cost savings than that. We want to be able to actually store our primary storage up in S3. But we want to keep our frequently accessed data locally. Right? And so whether it was backup applications, being able to store those backups in S3, or file shares, being able to store your file share storage in S3, for that use case, we delivered gateway cached volumes. And so gateway cache volumes, again, are iSCSI storage volumes. But in this case, the storage volume data is stored up in S3, not locally. And then we're just keeping a cache of that data on-premise. In either the gateway stored cached volume offering or the gateway cached volume offering, we provide the ability to take point-in-time snapshots of that data for backups. And those snapshots are stored in S3. So you may ask, hey, if I'm using gateway cache volumes and my volume data is already up in S3 and it's being stored with 11 nines of durability, then why do I need to take snapshots? So the reasoning there is for versioning purposes, right? If you want to preserve prior versions of your data, so for example, if there's an unintended user action on-premise and your user accidentally deletes a bunch of data and you need to recover to a prior version of your volume, you can create a new volume from a snapshot that you've taken. We've also added the ability to support bandwidth throttling. So we had customers that said, hey, I want to be able to store my data up in S3, but I may need to throttle that down during the daytime and increase the bandwidth that's available to the gateway in the evening. And so you can configure that through both our management console as well as through our API. And then finally, we supported both Linux and Windows iSCSI initiators. Right? And so that allows you then to mount your storage gateway volume to both a Linux on-premise application server and a Windows on-premise application server. So I'll now take you through 3 of the use cases that we targeted with the storage gateway, and I'll talk through a little bit about what the architecture would look like. So the first is, as I mentioned already, corporate file sharing, right? So home directories, departmental file shares, and so with file shares, with the storage gateway, you can now store using gateway cache volumes. Store your file share storage up in S3, and just keep your recently accessed files on-premise. And so if we look at what the architecture would look like in that model, so on the left-hand side, you see your data center, a host running the VMware hypervisor, and the storage gateway virtual machine. And on the front end, the storage gateway would expose an iSCSI interface that you would then mount to your on-premise, either Windows or Linux file server. And then your users would then connect to that file server over CIFS or NFS, right? So to them, it would appear as just another network share. When your user writes a file to the file server, it's then sent over iSCSI to the storage gateway volume. We store that file locally on either direct attached, SAN, or NAS storage in your data center. And then we asynchronously upload that file, that piece of data, up to Amazon S3. So the reason we're storing it locally is because, again, we're keeping recently written, recently read data on-premise for low latency access, right? And then we're uploading it to S3 over an encrypted SSL connection. And we're storing it encrypted in S3 using S3's server-side encryption capability. If your user then does a read of a file, so if they go to the file share and they double-click a file to open it, the storage gateway will check the local cache for that file. If it's there, they'll deliver it over iSCSI to the file server. If the file isn't there, then the storage gateway will grab that file from S3, download it, and present it to your user. So for files that are, again, most files that are recently read are the files that were recently written. And so for those files, your users will continue to get local performance. If your user tries to access a file that's stored up in S3, they may see a couple second delay, depending on where your location is compared to the Amazon S3 region that you're storing data in. But with the file share model, what this allows you to do then is to, for example, let's say you're storing 10 terabytes of file share data locally today. You can move that 10 terabytes of data over to a gateway cache volume up in Amazon S3, and your users can then start accessing that volume over their file share. If you then need to add more storage, you can simply increase your usage of your volume in S3, and you no longer have to scale on-premise. You no longer have to add any more storage locally. And because you're only paying for what you use in S3, as you increase your usage in S3, that's what you're going to be paying for. So you can provision up to a 32 terabyte volume up in S3, but you won't be paying for any of that S3 storage until you actually start storing data. The next use case is around backups. So whether it's something like TSM or an application like Backup Exec or Veeam, these applications are able to write over an iSCSI interface to disk. And so, for example, we have a large university using the storage gateway today, where previously they were backing up their data to a secondary data center that was pretty close to their primary data center, and they were running into two issues. So one was in their secondary data center they were running out of storage. And the second issue was they felt that their secondary data center was too close to their primary from a disaster recovery perspective. So now what they've done is they've taken their existing backup application and they've simply pointed it at a storage gateway volume, and they're now storing their backups in S3. They no longer have to worry about scaling that on-premise storage. And so in that model, again, the backup application server would connect to the gateway volume over iSCSI, and then as the backups are written to the gateway, we store the backups locally, and then we also upload it to S3. And then from the backup application's perspective, it doesn't know whether the data is being stored in locally or it's being stored in S3, right? All it sees is the iSCSI interface. And we're transparently in the background handling where the retrieval of that data should come from. The last use case I want to touch on is disaster recovery. So I mentioned that the storage gateway enables you to take snapshots of your volumes and store those snapshots in Amazon S3. Oh, sorry. Well, we've added the ability to access those snapshots from Amazon EC2. And so this allows you, in the event that your on-premise infrastructure is no longer available, you can reconstitute operations in Amazon EC2. And so the snapshots that you store through your on-premise gateway, you can then access from EC2 when you need to recover. So the value here is, if you think about a traditional DR setup, you probably have your primary data center and your secondary data center, and you're having to pay for all of that compute infrastructure in your secondary data center, even though you only need access to it either when you have a test or in the rare event, and hopefully this never happens, that you actually have a DR event. But with using EC2, EC2 enables you to only pay for the compute instances when you actually have to use them. So if you're using AWS and EC2 for disaster recovery, you only have to spin up and use those EC2 instances either when you want to test your DR workflow or when you actually have a DR event. If we drill in a little bit deeper into how you access the data from EC2, so there's a service called Amazon EBS, Elastic Block Store. It essentially provides block storage volumes for your EC2 instances running in the cloud. Enables your applications running in EC2 to have low latency access to their data. So EBS allows you to take snapshots of your cloud-based EBS volumes and store those snapshots in S3 as EBS snapshots. Well, the snapshots that you take from your storage gateway volumes are also stored in S3 as EBS snapshots. So what that means then is you can create an EBS volume from that snapshot, attach it to an EC2 instance, and then you now have access to the data that you wrote from your on-premise application. You would need to pre-bundle your instance with what we call an Amazon machine image, with your operating system and with the application that you're running on-premise to be able to access that data. So we've made getting started with the storage gateway a pretty straightforward process. You'd need to first provision a host on-premise, running, like I said, VMware hypervisor. And then you would download our software from our management console, deploy it on your host, and then you would allocate on-premise storage to that virtual machine. And again, that can be from either direct attached storage, NAS storage, or SAN storage. So if you're already using a SAN on-premise and you want to continue to use that investment you've already made, you can utilize a SAN for your cache. And then once you've done that, you would go to our management console or use our API and type in the IP address of your gateway VM. And what that allows us to do is to then tie your AWS account to the gateway that you've deployed. And then finally, you would select the, in terms of activation, you would select the AWS region. So which Amazon S3 region do you want to store your data in? And once you've done that, you can then start creating and mounting iSCSI storage volumes to your on-premise application servers and start storing data. So if we look at the architecture, what I'm highlighting here is the architecture of a gateway cached volume setup. So if we drill into that a little bit more, as I mentioned, your volume storage is stored up in Amazon S3, and you can then take snapshots of that and store them in S3. Now snapshots are differentials, right? So the first snapshot you take is a complete copy of your volume. But if you then write a couple of additional blocks to your volume and you take a snapshot, the second snapshot is only going to store those incremental 2 blocks of data. We're also compressing all of the data both on upload and download, and we're compressing both the volume storage and the snapshot storage in Amazon S3. If we look at the gateway virtual machine and the storage that you allocate for it, there's 2 types of storage that you would need to allocate to your gateway. So the first is the cache storage, right? And so the cache storage is your local cache for caching your frequently accessed data, right? Your reads and your writes. And then we ask you to allocate what we call upload buffer. The upload buffer is essentially the queue to get data up to Amazon S3. So when a write happens over the iSCSI connection, we store that data both in your cache storage, because it's a recently written piece of data, and we also store it in your upload buffer to queue it up for upload to S3. We're constantly uploading that data to S3, right? So there's not sort of a step that you would need to take to say, OK, upload this to S3. As soon as the data hits the upload buffer, it immediately enters the queue for upload to Amazon S3. And so you can imagine during the course of the day, your upload buffer will be filling up, and the usage in it will be filling up and contracting, depending upon your network connection, depending upon how much data is flowing in. So I want to show a little bit more about how the attachment of the volumes would work. And so I just want to make sure you can see. So what we're looking at here is the management console in AWS, right? And so I've accessed the console. I'm accessing my demo gateway. And this is a gateway that's actually running on a host in my office back in Seattle. And the gateway is storing data to the US West Oregon Amazon S3 region. So I've created a 5 terabyte iSCSI volume. And I can go to the gateway tab, and I can look at the local storage that I've configured. And you'll see that I've allocated 200 gigabytes of upload buffer, and I've allocated 250 gigabytes of cache storage for my gateway. So creating a volume is a pretty straightforward process, right? I can just click create new volume. And again, this is what I'm showing you is a gateway cache volume where the data is stored up in S3. So let's say I create a 3 terabyte volume. Call it my new demo volume, and create it. And so now this volume has been created up in S3, right? You're still not paying for any of the usage up in S3. You've just provisioned it, right? So now you have the 3 terabyte volume up in S3. So then what I can do is go to my iSCSI initiator. So in this case, I'm accessing a Windows host again in the Seattle office, a Windows file server. And if I refresh the iSCSI initiator, I'll see the new demo volume that I just created up in S3. And I can click on it and connect to it. And so now that I've connected to it, I can go to Windows Disk Manager. And I'll see this. So this is the 5 terabyte volume I created earlier. This is now the 3 terabyte volume that I've just created. And again, the volume is up in S3, and it's being exposed over an iSCSI interface. So again, to Windows, it's just another disk. I can then initialize it. I'll choose GPT because it's over a 2 terabyte volume. And then I can go through the process of creating a new volume from it. It's important to choose quick format for a new volume. I'll get into why that is. I think it should be pretty obvious. So once I've done that, this will probably take a couple minutes to format. But once I've done that, I'll just show the previous volume I created here. So once I've done that, I now have a volume that I've essentially attached to from my on-premise application server, right? So I can take a file and copy it over to the volume. And what that's doing now is it's writing the data over iSCSI to the gateway. We're storing it locally on that cache storage, right? So in my case, it's storing it on my host in Seattle, right? I have direct attached storage to that host. And then transparently, it's also uploading that data to Amazon S3, right? So if I open that file, it'll in this case it would pull the file from my local storage, right? But if I haven't accessed that file in a long period of time and my cache is full with other more recently written or recently read files, it would have pulled that file down from S3. So hopefully that gives you a sense of how you would actually interact with that volume on premise. So if we look at how to actually size your upload buffer. So when you think about sizing the upload buffer, again, it's about queuing the data before it gets up to S3. You want to think about the approximate amount of data that you're going to be writing on a daily basis. So if your backup application is writing a terabyte a day, then you would want your upload buffer to be about a terabyte in size. But it is recommended that your upload buffer is at least 150 gigabytes in size. The sizing of your cache storage depends on the use case. So if you're looking at the storage gateway for a backup type use case, then you'd want your cache storage to be at least the size of your upload buffer. I'll get into why in just a little bit. If you're looking at it for example, a file share use case, where you want your cache to be larger to store data for quick reads, then our recommendation is to look at the amount of storage you have today in that file share and allocate about 20% of it. So what we've seen is, this will vary, but what we've seen is typically about 20% of the file share will be actively accessed. So if you have 10 terabytes of file share storage, you can create a 32 terabyte volume up in S3 to store that data, but you'd want to add about 2 terabytes of cache storage locally. You can always add more cache storage. You can't remove cache storage. And the reason is because your cache storage is your durable store of data. So if we look at the path that data takes when it hits the gateway, we store it on your cache storage disks, right? And then we acknowledge the write back to your application. Right? So it's not like we're writing it to S3 and then acknowledging the write. That happens transparently in the background. So when you think about the durability of the data you're writing to the gateway, well, so once it's stored up in S3, you're getting 11 nines of durability. But until then, the durability that you're getting is really dependent upon the durability of your cache storage. Right? So if you're running, let's say, RAID 5 or RAID 6 on-premise today for your file share storage, you'd want your cache storage to also be backed by RAID 5 or RAID 6. Right? The data is also written to, as I said, it's written to the cache storage and it's also written to the upload buffer. But for the upload buffer, we're simply writing it to memory and then we're uploading it to S3. So your cache storage is really the durable data store. So what that means then is your cache storage needs to be large enough to store your dirty writes. And when I say dirty writes, I mean data that hasn't yet been uploaded to S3. And so that's why when you think about a backup use case, right? So for a backup use case, you may say, look, I just want to store all my backups in S3. I'm rarely ever going to access my backups. When I do, I'm OK with the backups not being locally. So why do I need any cache storage at all? And that's because your cache storage is that durable store. So your upload buffer does need to be large enough to store the dirty data, but so does your cache storage, right? So what happens if either of these fill up, right? What happens in that event? What are the error cases here? So if your upload buffer fills up, then the cache storage will continue to be able to process reads and writes from your application, and will now start uploading data from your cache directly to S3. But you won't be able to take snapshots during that time period because the upload buffer also tracks snapshots. If your cache storage fills up, well, I mean that's fine, right? I mean ideally your cache should always be full of data, right? If it's not full of data and you do a read, well we'll put that piece of data in your cache, right? But what you want to avoid is your cache getting full of dirty data. And so we have alarms in place. So when you go through the process of setting up a gateway, we by default set up alarms such that you get notified in the event that your upload buffer fills up. You get notified in the event that your cache storage fills up with dirty data. Because what happens when your cache storage fills up is now we have no place to put that dirty data. Right? And so we have to stop the writes over iSCSI. We have to block future writes from coming in until we can upload that data to S3. So you want to avoid that condition. And that is why you can add more cache storage, but you can't remove cache storage. Because the cache is storing your dirty data, so if you remove storage, you're potentially removing data that hasn't yet been durably uploaded to Amazon S3. We also recommend that you allocate separate disks for your cache and your upload buffer. And so I'll jump back to the diagram to explain it. So the reason is the cache is about optimizing the performance over iSCSI. Right? It's handling the reads and writes from your on-premise application. And the upload buffer is about optimizing performance to S3. It's about pushing data as quickly as possible, compressing that data and pushing it as quickly as possible to S3. So ideally, you want to have two separate disks. So you have two separate spindles, one handling the I/O from your application, one handling the I/O to and from S3. And so if you're looking at it from a VMware perspective, that would be two separate data stores. Now come back to the point I made earlier, which is around quick format and full format. Right? So again, you're paying for the volume usage that you store up in S3. So if you provision a 32 terabyte volume, you haven't stored any data yet, you're not paying for any of that volume usage. Right? If you then go to Windows and you do a full format, well, Windows is going to write, even if it's zeros, it's going to write chunks to the entire volume. And we're seeing that data over iSCSI. We're just going to upload those blocks up to S3. Now, it's highly compressible, but it's no longer 0 gigabytes of storage. Right? So you want to be very careful when you're creating a new volume from scratch that you use the quick format option. Similarly, from a virus scanning perspective, right, if you're when you're running virus scanning on the volume, the iSCSI volume, you want to use a virus scanning software that'll do the scanning on reads and on writes. You ideally don't want to be running a virus scanning software that, for example, once a week goes through and scans your entire volume, right? Because you can imagine then your cache storage is about keeping your frequently accessed data. So in the event that your virus scan software then starts reading all of the data, it'll download all of the data from Amazon S3 to your cache storage, right? And then that'll impact the performance your users are seeing, because their recently accessed files will now be essentially evicted from the local cache. So you want to make sure that your virus scanning is run on just the reads and writes that are happening to S3. So with that, I hope that gave you a good sense of how the storage gateway works, what the key use cases are, and what are some of the things to keep in mind when you're allocating local storage or provisioning storage up in S3. I know that following this, there's a reception, so I don't want to keep you from that. Having said that, I'll be up here for the next 10, 15 minutes or so. So happy to take any questions you have up here on the stage following the presentation. I want to thank you again for your time, and I hope it was informative. Thank you.